What specific problem does the Babel model aim to solve in the multilingual LLM landscape?
The Babel model aims to address the significant gap in multilingual support within the landscape of large language models, LLMs, particularly in the open-source domain. Existing multilingual LLMs tend to prioritize languages with extensive training resources, often neglecting languages spoken in less developed regions, such as Hindi, Bengali, and Urdu, despite their large speaker populations. By focusing on the top 25 languages that cover over 90% of the world's population, Babel seeks to make LLMs more accessible to a broader global audience. Additionally, Babel emphasizes optimizing the data cleaning pipeline to ensure high-quality training data for these underrepresented languages, thereby enhancing their performance and usability. Ultimately, Babel's goal is to provide a more equitable and effective multilingual LLM that serves a diverse range of languages and speakers.
How does the proposed Babel model work? Please illustrate its methodology step by step, including its data collection, cleaning, model extension, and training phases.
The proposed Babel model operates through a structured methodology encompassing data collection, cleaning, model extension, and training phases. First, data is collected from diverse sources including Wikipedia, textbooks, and web-based corpora to ensure a rich dataset that covers the top 25 languages spoken by over 90% of the global population. Next, the data undergoes a rigorous cleaning process, utilizing an LLM-based quality classifier to filter out low-quality content and remove duplicates, ensuring high-quality training data. In the model extension phase, Babel's architecture is enhanced by adding new layers through a structured layer extension method, which maintains the integrity of the original model while increasing its parameter count. Finally, the training phase consists of two stages. The first focuses on recovery using a diverse general training corpus, while the second emphasizes continuous training with a higher proportion of low-resource languages and textbooks, ultimately leading to strong multilingual capabilities and performance benchmarks across various tasks.
Can you provide a simple example of how the layer extension method is applied in the Babel model and how it affects the model's performance?
The layer extension method in the Babel model involves adding new layers that are identical in architecture to the original layers, specifically in the second half of the model. For instance, the authors experimented with inserting layers between existing layers or appending them after the original model. The findings indicated that inserting new layers within the existing architecture resulted in only minor performance degradation, while appending layers directly to the end led to a significant decline in performance. This suggests that gradual expansion through layer insertion is less disruptive to the model's learned representations. Ultimately, the optimal approach was found to be duplicating original parameters without introducing noise, which maintained the integrity of the model's performance during training.
What are the advantages of using the Babel model over existing multilingual LLMs, especially concerning languages with limited training data?
The Babel model offers significant advantages over existing multilingual LLMs, particularly for languages with limited training data. Firstly, it focuses on the top 25 languages by number of speakers, including many low-resource languages like Hindi, Bengali, and Urdu, which have been largely neglected by other models. Babel employs an optimized data cleaning pipeline and a robust LLM-based quality classifier to ensure high-quality training data, addressing the scarcity of resources for these languages. Additionally, Babel's innovative layer extension method increases its parameter space, enhancing performance without disrupting the model's stability. As a result, Babel demonstrates superior performance on multilingual tasks, particularly for low-resource languages, outperforming competitors like Qwen 2.5 and Gemma 2 across various benchmarks.
How was the performance of the Babel model validated? Discuss the datasets used for testing and the metrics applied to measure its effectiveness.
The performance of the Babel model was validated through comprehensive evaluations against comparably sized open-source and commercial multilingual LLMs across various multilingual tasks. The datasets used for testing included MMMLU, M3 Exam, MGSM, XCOPA, XNLI, and Flores 200, which cover a range of categories such as world knowledge, reasoning, understanding, and translation. For accuracy measurement, the evaluation metric employed was accuracy for all datasets except for Flores 200, where the CHRF++ score was used to assess translation quality. Babel 9b base achieved the highest overall performance among 10 B-size models, while Babel 83b outperformed other open large multilingual LLMs, demonstrating strong multilingual reasoning, understanding, and translation capabilities. These results highlight Babel's effectiveness in addressing the needs of both high-resource and low-resource languages.
What specific results were achieved by the Babel model in comparison to other models in its class, and which metrics were used to evaluate these results?
The Babel model achieved significant results compared to other models in its class, particularly in the 10 B-size category, where Babel 9b base outperformed Gemma 2 to 9b base by 3.9 points, achieving an average score of 63.4. It excelled in specific benchmarks, achieving the highest scores on XCOPA 89.2, MGSM 43.4, XNLI 70.9, and Flores 255.1. In the 83B size category, Babel 83b achieved an average score of 73.2, surpassing Quen 2.5-72b by 3.4 points, and also led in MMMLU 76.3. M3 Exam 72.1, XCOPA 92.8, XNLI 76.6, and Flores 258.8. The evaluation metrics used to assess these results included accuracy for most datasets and the CHRF++ score for translation tasks in FLORES 200. These results highlight Babel's strong multilingual reasoning, understanding, and translation capabilities, positioning it as a leading open multilingual LLM.